Hi everyone, I'm Simon from HomeSite. Today I'm going to be doing a network tutorial specifically around home networking and some of the bits that you can do to improve your network. So let's go! So in this video, I'm going to take you through your home network, starting off with that home router that's typically provided by your service provider. It's a router, it's a switch, and it's a wireless access point, and it's a firewall as well. So we're going to break down each one of those components and help you understand how it could be made better. Now, you'll notice that I'm not in my normal setup. Now, I was away with work this week and COVID is still roaring away, so I was bored and I thought, great, I'll use that time to do this little network tutorial I've been trying to do for a while. So hopefully you'll like this video. Please give it a like down at the bottom if you do. Hopefully you're liking the sort of content that I do around Home Assistant and all that sort of thing, so please subscribe to my channel to make sure you don't miss out on any new videos. Great, thanks very much. I read a lot of posts on Facebook and various places, and there's some real network fundamentals that people just aren't quite getting right. So I think it's time that you all learn what you need to know. So let's give you a little helping hand. So I'm going to be using this whiteboard session, so please excuse my probably terrible drawings, but I'm going to do my very best to explain and use pictures where I can. So the first thing I want to debunk is this thing here. Well, most people call it a router. Now, it's typically the thing that your internet service provider gives you when you sign up to an internet service with them. You can buy third-party ones, you can buy ones that are compatible with your internet service provider, but most people call this a router. Now, I'm not going to dispute the fact that it does have a router inside it. It does have a routing function, but it's also a switch. It's also a wireless access point, and it's also a firewall. Now, I'm going to break down each one of these individual components, which hopefully should be the first step in understanding your network. So, what is a router? A router is the symbol for a router is shown a bit like this. It's a circle with 4 arrows on it, 2 pointing in, 2 pointing out. Now, a router connects one network to another network. Now, your router at home will typically connect your local area network to the internet. So I'm going to call this your LAN, your local area network. Now, what's important to understand is that a router has an IP address on this side of the network and one on this side of the network, and they must be different for a router to function. So this one is typically given out via something called Dhcp, the Dynamic Host Control Protocol, the thing that gives out IP addresses. And this will typically be given out by your ISP, who will be allowing you to connect to the internet and giving you that either static IP address or a DHCP address. Now, if you've got a static IP address, that means that it doesn't change. If you do have a DHCP address, which is most residential internet connections, as I understand, certainly in the UK, that's standard practice. If you do have this, if you're wanting to get to your LAN, where you may have your Home Assistant from the internet, then you will need to know what the IP address of this device is. And there's various things like duck DNS or dynamic DNS, which will give you your IP address of your device, and it will update it. If it were to change through this DHCP, if you were to be given a different IP address next time you connected, or next time that your router connected, then this can be updated. So there can be a service that runs here where you basically send your information through the internet out to what we call a dynamic DNS service. Now, Home Assistant supports DuckDNS through some of the add-ons, so that's normally quite a good one to use. Now, by giving it a dynamic name, the name when the IP address changes, you can use the name from your device here, and through this thing called DNS, the dynamic naming service, your computer will put in the whatever it's called .duckdns.org. So it might be simon.duckdns.org. So when you look up that address, that URL, your computer is going to actually go to a DNS server, and the DNS server is going to ask dynamic DNS what your current IP address is, and that's going to then forward you directly onto your router, which is going to give you access with a few more steps, of course, as well. Right, so that's the IP addressing side on the internet side. But what about your local IP address? So I'm going to call this your local area network, your local IP address. Now, typically, this will be either starting with 10 dot something dot something dot something and a subnet mask of 255.0.0.0. That one, I'm going to call this one an A because it's a class A. It could also be a B, which would be 172.16.0.0, and the subnet mask will be 255.255.0.0, or it's going to be a class C, which will start 192.168.something.something with a subnet mask of 255.255.255.0. Okay, so what does that mean, and why am I telling you about these IP addresses? Well, they're really important. Every unique device on your network has to have a unique IP address. If it doesn't, you'll have clashes. Now, it's important to understand the different classes. Well, it's important to understand the relationship between the IP address and the subnet mask, because the subnet mask is really telling you which part is the network and which part is the client. So it's actually called the network portion and the host portion. So let me explain what I mean. If you have an IP address of 192.168.0.100 and a subnet mask of 255.255.255.0. Well, where the 255s, the 255s end, this bit here is your network. So this 192.168.0 is your network, and any host here between 1 and 254 will be able to talk to each other on the same network. So this gives us 254 usable addresses. Now, if we were using a class B, we had 172.16.100.173 and 255.255.0.0. Now this moves the network portion to this. So this 172.16 is now our network portion, and this 100.173 is our host portion, which means that now these individual parts are called octets, by the way. So you have 4 octets in an IP address and a subnet mask. Now, so these first 2 octets will remain the same for any device on the same network or the same IP address range, and these 2 parts here can change. So you could have 1.206, would be on the same network as 7.123. So this gives you, by making your subnet mask 255.255.0.0, this gives you 254 times 254 usable addresses. Actually, I think it's more than that. It's a lot. It's a lot of IP addresses. Now, more than you could probably ever fit onto your home network. Now, why have I given you these ranges that you can use? Or am I just psychic? Well, no, I'm not psychic. These are the IP address ranges which are reserved for use on a local area network. So that is what will be configured on your router. Now, you could choose 8.8.8.8 as your IP address, for example. However, your router will naturally try and route that to the internet. So these addresses here will not be routed to the internet, but if you used an IP address of 8.8.8.8, it means that you would never be able to get to Google's DNS server, because Google's DNS server is 8.8.8.8. Okay, so that's probably enough about IP addressing. However, if you want to know why this magic number of 255 exists, this is an 8-bit. I apologize if I'm losing you. I will go simpler again in a couple of minutes. So all of these octets are 8 bits long. Now, what I mean by a bit is 8 bits of binary. And so if I write 255 in binary, here goes 1, 2, 3, 4, 5, 6, 7, 8. 8 ones, 1, 2, 3, 4, 5, 6, 7, 8 ones, and this is 8 zeros and 8 zeros. Don't know how many are actually there, but you get the gist. So this line moves to where the ones stop and the zeros start. So you could have an IP address, a subnet mask of 255.255.240. That's at 4. 240.0, and that would steal some of the ones. It would move the line this way a bit, and so it means that you're stealing some of this octet for this one. So you might be, I can't think exactly off the top of my head how many bits we've just stolen. We could probably work it out, but I won't because it's pretty dull. But this means that you would have more than 254 addresses because we've stolen a couple of bits from this one as well. Okay, that's well enough, way too much on IP addresses already. So coming back to this. So we've talked about what a router is, and we've talked about IP addressing in there as well. What does a switch do? And a switch symbol is shown like this. A switch allows multiple devices to connect together. Now, a switch is a wired device, so if you had a device here and a device here, let's call that A and B. We've got a network range of 192.168.0.0 and a subnet mask of 255.255.255.0. So what we can say here, this is .5 and this is .6, because we know it's only this last octet which is changing. So we know that the first bit is 192.168.0. So I'm just going to draw my line there. So we know that 5 and 6 can connect together on a switch, and all a switch is going to do is pass the packets from here into the switch and out here, and obviously vice versa as well. Now, what if we have another, I'm going to draw these in blue, we could have a device A and B over here, and they might have an IP address of 10.0.0.0, but we don't know how much of that is the network portion until we write the subnet mask. So 255.0.0.0. Okay, so then we'd have to say that this one is network address is, so remember we're going to draw that line there. So this network address is 1.2.3, let's say, and this is 100.7.9. Now obviously I just made those numbers up, they're not that relevant, but it means that these two can still talk to each other, and interestingly they can be connected to the same switch. And when this A sends a message to B, it can go through the switch and back out here. Now if A wanted to talk to A over here, now they are not on the same network, or they're certainly not in the same IP address range. So what do we need to do about that? Well, that is where our router comes in. So we could have a router that has got an interface on the B network and an interface on this A network. So this might be .1, and if I pick the right color, this might be, let's go for that, 1.2.1, for example. Now if A wanted to send a message to A over here, it would send it to its default gateway. Now that's another term that I'm just bringing in now, default gateway, not one I just made up, a default gateway, DG. Now when you're setting your default gateway on this device over here, say, it would have to be in the same network range, so 192.168.0. something. Now it's traditionally the first or last IP address in the range. Now in this case it's going to be, I'm going to call it .1. So my default gateway, DG over here, is .1, and over here I'm going to say my default gateway is 1.2.1. Okay. Now, if this device here, the blue A, was trying to send a message to this one over here, 192.168.0.5, it would send it to its default gateway because it doesn't know where to send it. It's like, I don't know where to send my traffic, where shall I send it? Well, I'll send it to my default gateway. And this will either say, well, I know where this route is, I know it's out here, so it's going to route the traffic from here across, or it might have a default gateway as well, which might be the internet, and it sends it out there. For example, if this one went to try to go to this magical 8.8.8.8, it might go, well, I don't know where that is. The Google public DNS, which is 8.8.8.8, is over here. This could be any IP address. And Google will know where to send that information back, because part of the information that gets sent, you send the source, you send the destination, and you send what we call a payload, as well as a bunch of other stuff. So why am I telling you this? Well, this is actually quite useful because it means that you could have your normal internet traffic on a nice simple network over here, and you could have your Home Assistant traffic on a separate network. Now they could be connected to the same switch. Now bear in mind, earlier on we said that that router that your internet service provider gives you is a router, it's a switch, it's a wireless access point, and it's a firewall as well. Now so you could set up your router to route between two networks on the same switch. Now equally, this could be different switches. Now if I get this right, I should be able to delete this switch and show two separate switches. And a switch over here as well. So there we go, so now we've got two separate switches connected into your router with different IP address ranges. Now, an ISP router is often quite basic in terms of functionality. Sometimes it's fully functioned, however the ISP locks it down. So it really does depend what router you get. Now personally I don't use my ISP router, I use a Dhcp, which I really like. I've used Dhcp for years, They've always been pretty good. They support VPNs as well and that sort of thing, so a virtual private network, so the ability to get in from the internet and connect directly to my local area network as if I was sat in my office at home. Now, the other way of doing this is by using a VLAN. Now, I'll talk briefly about a VLAN because I see these talked about as well. Now, a VLAN gives you the ability to have a single switch. Like I mentioned earlier on, when we had two different IP address ranges on the same switch, it's not best practice to do that. Best practice is to use something called this VLAN, this virtual local area network, because that keeps the traffic properly segregated. However, it does mean that you need a switch that supports it. Now, there's a few ways around it, and I'm probably do a follow-up video and we're going into a bit more detail. But the essence of a VLAN is that when a device in this red network, we don't care what IP address range it is, but let's just call it this red network, is connecting to this switch, we're going to connect it into a port which is in this red VLAN. Now I'm going to call this VLAN 1. So you put all of your ports into specific VLANs. Now it might be that we've got a bunch of stuff in this VLAN 1 and a bunch of stuff that we want to be in VLAN 2. So we connect our ports up, we configure our ports, and these devices then can only talk even if they changed their IP address of this device. It still couldn't get to this one over there. Now VLANs have to have different IP addresses on those different VLANs, otherwise it just gets a bit confused. Now the other thing to note is you can have some ports called a trunk port. Now a trunk port is basically, if you imagine when this red device here sends traffic into this port here, now this doesn't know that it's physically separated from this. However, the switch here, when that packet comes in, a bit like I showed you a minute ago with that source and destination, it adds a little tag onto that packet as well, and it adds this little VLAN ID, and so it will send it with this VLAN ID, and it will be allowed to go out of ports with that matching VLAN ID. So traffic from here can never go out to a port 2. Now sometimes we want the ability to have either another switch, oops, wrong colour. We might want the ability to have another switch. We might have run out of switch ports, so we need that to go into a trunk port, and that trunk port will allow us to preserve what we call this VLAN tag that gets added onto the traffic that comes through. So it means that if we've got a red port down here, it means that this can still only talk to this, even if you have other networks on there as well. Now, the challenge with this is this needs to be what they call a managed switch, which means that basically you can log on to the thing, you can change some configuration, and most switches that you would buy cheaply wouldn't support being managed. So you're looking for the term managed switch if you want it to support VLANs. You can get some fairly cheap managed switches. Personally, I use a Cisco, but I like my Cisco kit. It tends to be a little bit more expensive, but there's some good stuff out there. Now, why else might you want to have a trunk port? You might want to have a trunk port if you have a router that supports VLANs as well. So this would also be a trunk port and allows you to have what they call sub interfaces. So the sub interfaces here means that it would support multiple IP addresses, so it would manage the traffic from the red and the blue separately as well. So it might say, well, actually I've got a interface in this red network with it ending at a .1 and an interface in the blue network, so this VLAN 2, and that's got an IP address of .2, and that would allow you to use one port to it rather than multiple ports, and would allow you to connect to that lovely fluffy cloud and get out to the internet. Now equally, that gives you the ability to segregate your network, so it might allow you to use your network for normal home and internet browsing and your Home Assistant network. Now Why might you do that? Well, some people would say that you should segregate your network based on the purpose, and that would prevent any issues on the blue network causing any issues on the red network, kind of. Now, personally, I don't necessarily suggest that you all jump out, buy a managed switch and buy a router that supports VLAN on a stick method, or just VLAN trunking, or 802.1q, which is the standard, because it's not really needed that much on a home network, if I'm totally honest. It's useful to know, it's useful to understand, but the benefits for a home network are fairly minimal. Now, so what would I do if I were you? If you know this stuff already, then I don't know why you're watching this video, maybe just to look at my lovely smiling face, but you've already got the experience and the understanding of this network and this networking elements, and so you already probably understand the benefits. Now, maybe you're wanting to do it for a hobby, maybe you're wanting to just learn a bit more about networking, which is fine, which is a perfectly acceptable reason, in which case, go out and get yourself a cheap managed switch. But the real technical benefits aren't that high. Now, if you're getting to a position where you've got 200 network devices on your network, then you might want to change your IP address range. Now, personally, on my network, I have that Isp router that I mentioned earlier on, and that supports this 802.1q method, so this router that supports multiple VLANs. I do have a managed switch. Now, I also have a wireless access point, which supports VLANs as well. So rather than having this as a normal access port like this into a certain VLAN, it supports VLAN trunking, and depend on the SSID. So I've got my what I call my OT, my operational technology, so my home assistant and all of my devices, they all sit onto this OT SSID, and I have another one which is just my home traffic. Now, these put this into the red and the blue networks, and that tag is then preserved into my switch and ultimately out to my router. And if I on my iPhone want to connect to my home assistant, it goes through the switch, out to the router, back through the switch, and then eventually onto my red network. So hopefully that makes sense. So I've talked there a little bit about wireless access points. So I am going to scroll down here a little and talk a bit more about wireless access points. So a wireless access point. Now, I mentioned that this is typically built into your router as well, that you buy from your ISP, or is provided from your ISP. Now, what is a wireless access point? Well, basically it is an antenna which is connected to a switch. Imagine all of that traffic from your wireless going into your switch just wirelessly. It does exactly the same function. It still allows traffic to go in and out, still hands out IP addresses where it needs to, it still supports everything else that you need it to. Now, there's various standards, 802.1 A, B, G, N. These are all wireless standards, and the higher you go, the better they are. So we started off here with really slow wireless, and now we're at 100 plus meg. There's also a couple of different frequencies that work within wireless. So you get a 2.4 gigahertz frequency. There's also a 5 gigahertz. Now, why am I talking about frequencies? It's important because 2.4 gigahertz is a very congested wireless band. Now, there's quite a lot of wireless bands out there. Most of them are licensed for specific things like the police, digital TV, all sorts of anything wireless that uses a radio frequency. Now, 2.4 gigahertz is also used by our friends Zigbee or Z-Wave or all sorts of things. Wireless microphones, wireless doorbells. You can use, there's various channels in here, 13 I think to be precise. There's lots and lots of things that use 2.4 gigahertz, not just wireless. So if you're finding that you've got issues on your wireless, things are dropping in and out, it'd be worth taking a look at your other wireless devices and possibly even moving to 5 gigahertz if you can. Now, not all devices support 5 gigahertz, so you do need to preserve your 2.4 sometimes as well, but you can try and get things onto 5 gigahertz. Now, some wireless access points that are built into your routers only support 2.4 gigahertz. They might be supporting, probably not A or B because they're really old, but maybe G, maybe N. Now, why is this important as well? Well, it's like if you buy a combined thing, it compromises in lots of areas. You've got one processor that's doing all of your network switching, that's including your wireless, your routing and your switching. It's all being done by the same piece of hardware. Now, typically, if you get more wireless traffic, you can slow down your routing, or if you've got lots of routing going on, you can slow down your wireless. You've got lots of switching going on, you can slow that down as well. Just going to talk about your router again, your combined router. Now, if it has this routing, this switch function, and this wireless access point function. Now, personally, the first thing I would do is buy a separate router, or just disable the wireless function from it, and buy yourself a separate access point. Now, a lot of people are going to turn around and say, get an Ubiquiti wireless access point because they're great. Now, yes, they are pretty good. However, there are alternatives as well. Personally, I use a Ruckus. Now, I bought my Ruckus for £15 on eBay. It is amazing. It supports everything that I would expect it to do, but it doesn't come with Ubiquiti price tag. Now, I will admit, this wasn't a brand new Ruckus. Brand new, they're more like £300, £400, but for some reason, the second-hand resale value of them can be quite low, so you can buy a reconditioned one for very, very cheap. So that might be my top tip, number one. Get yourself another switch as well. Now, if you imagine you've got 10 lanes on a motorway. Now, those of you that live in the UK, we can't even imagine having 10 lanes on a motorway. We're more like 3 or 4. But if you had 10 lanes of a motorway, you've got, I don't even know how many that is, but you can send these many devices can send traffic at the same time. Now, by buying a separate switch, you're upgrading the number of lanes on the motorway. You're increasing your bandwidth, and it is really important because if you can get your devices connected into your switch, lifting the load off of your wireless access point and certainly off of your router, it means that they can talk freely along more lanes of the motorway. Now, this is measured in gigabits per second, not gigabytes, but gigabits. So that's the same as your speed on your internet. It's measuring exactly the same, but it's gigabits. Now, my switch supports around 2 gigabits per second. Not that I've tested it, but that's pretty quick. So if I had, so I can send. Now that's pretty quick for a home switch. If the switch that you buy doesn't tell you the number of gigabits per second that it has, that it's able to support, then it's probably not that good. So that is my top tip number 2. Now, my top tip number 3 is to buy yourself a new router, but I would do it in that order. So start off with your wireless, upgrade your switch, and then upgrade your router. Now, you could end up with a setup with having your router from your ISP, and that's still perfectly functional and able to connect you to the internet. Then you have an upgraded switch, and you have a separate wireless access point, be that Ubiquiti or Ruckus, or to be honest, there's lots of others out there, and that's connected in here. Now, by splitting out the 3 devices, it means that you're lifting the processor load off of your router, off of your switch, and off of your wireless access point, and allowing them to do their job independently. And it means that most of your network traffic doesn't need to go past your switch and towards your router. Because if you've got your Home Assistant and you've got a myriad of devices connecting back to a Zigbee hub, for example, and then you've got a load of other devices which are connecting to your either your wireless network or directly into your switch, it means it doesn't need to go anywhere near that crappy ISP router that they dish out. So I really hope you found that useful. If there's anything you want me to go over, please put it down in the comments and I will absolutely do you another video just to go over some of those other elements. I'm thinking about doing another one as well, some greater depth in terms of network address translation, so how we forward port through our firewalls and our routers to make our Home Assistant publicly accessible and that sort of thing. So if you put your comment down below, I'll make sure I cover that content or recover it back in my next video as well. Give this video a like and give my channel a subscribe to make sure you don't miss out on any future videos. Thank you so much for watching. I'm Simon from Homesite.